So we're going to be taking a look today at graphing motion. Now we've taken a look at graphing motion in terms of understanding position versus time graphs. We found the slope of these graphs give us the velocity of the graph. Well, we can also take that velocity quantity and we can graph that on a velocity versus time graph. The slope of this is going to give us the acceleration of the graph because acceleration is the change in velocity over time, which is the slope of the graph. Now we can also graph the acceleration versus time, but the slope doesn't give us any useful information. We can still get other information from an acceleration versus time graph though. The other way we can solve out for information in a graph is to get the area underneath the graph. So in an acceleration versus time graph, the area under the line gives us the velocity of the object over the specific time interval. And in a velocity versus time graph, the area under the line gives us the position over that time interval. So if we compare these two side by side, we have three graphs of motion: position versus time, velocity versus time, and acceleration versus time. To go from position versus time to velocity versus time, we look at the slope. To go from velocity versus time to acceleration versus time, we look at the slope of that graph. To go backwards from acceleration to velocity, we look at the area under the graph. And to go from velocity to position, we look at the area under the graph. So here we see a velocity versus time graph. It's a constant velocity of 5 meters per second, meaning that for every second that goes by, it gains 5 meters of position. So if we solve out for the area of this graph, our velocity is 5 meters per second, and our time is 5 seconds. Length times width, because this is a rectangle, is velocity times time. 5 meters per second times 5 seconds, 25 meters. We get the displacement in 5 seconds. Now, this is a velocity versus time graph once again, where we see a change in the velocity. Notice at 0 seconds, the velocity of our object is 0. And at 6 seconds, the velocity of our object is 6 meters per second. In order to get the area of this graph, we need to recognize that this is a triangle. The area of a triangle is 1/2 of the base times the height. So 1/2 times our base, which is 6 seconds, times our height, which is 6 meters per second, will give us 18 meters for the displacement. Now, if we look at this velocity versus time graph, we see once again a constantly changing velocity going from positive 30 to negative 30. We have two areas in this graph, one in the positive region, one in the negative region. Now, when we say the area under the graph, we're referring to the area between the line and the x-axis. So notice that we have two areas cordoned off, and visually we can see that they're about the same size. If we find the area of area 1, 1/2 of the base, which is 3 seconds, times the height, which is 30 meters per second, we're going to get an area of positive 45 meters. Area 2, going from 3 to 6 seconds, is a base of 3 seconds, and a height of 0 to negative 30 is a height of negative 30 meters per second. 1/2 of the base times the height will give us a negative 45 meters. Adding them together gives us a displacement of 0, which means the object moved out a distance and returned to its starting point. If we want to find the slope of this graph, if we go from positive 30 at 0 seconds to 0 meters per second at 3 seconds, we see the slope is negative 10 meters per second squared. Here's an acceleration versus time graph. Now, on an acceleration versus time graph, the only quantity we're interested in finding is the area under the graph. That's going to give us the velocity. So 10 meters per second squared times 5 seconds will give us a change in velocity of 50 meters per second. So if the object started at rest, it has gained 50 meters per second and ends at 50 meters per second. If it started at 10 meters per second, it still gains 50 meters per second, which means it's now moving at 60 meters per second. And that's where we're going to end the notes for today.